How's it going, everyone? This is Jamie here with FLA Tutoring, and today we're going to briefly go over integers and describe what they are and how we can determine if a number is an integer. So integers are positive and negative whole numbers and the digit 0. And you can see that that's written up here, positive and negative whole numbers and the digit 0. I'm going to write that as another type of shorthand as a way to help you remember what integer means. So sometimes I write this as plus and minus, so positive and negative, WN for whole numbers, and then I put a semicolon, and I put 0. So that's a shorthand of writing what integer means. And so when we're talking about positive and negative whole numbers here, we're talking about numbers that are both on the left side of 0 in the negative and on the right side of 0 in the positive. So if I have a number line here, and I have 0, 1, 2, and I have -1, -2. As you can see here, this is the negative side here on the left. This is the positive side here on the right. And each of these values that are at the marked lines are whole numbers. So -2, -1, and then we have 0 here, which is also an integer, 1, 2, and it will actually continue on forever. And every single number that's a whole number will be a part of our set of integers, whether it's positive or negative. And if you weren't sure what whole number meant, a whole number is a number that has no fraction or decimal, there we go, decimal remainder. And so for us to think about this and to see some examples will help us understand what that means even better. So some examples here that will be easy to recognize would be just your regular digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for example, we could say 1, and I'll put a comma to distinguish numbers. 2, 3, and if we keep going on in that pattern, we'll see those whole numbers. Of course, we could have -1, -2, -3, and so on and so forth. It'll keep on going. Now, just because a number is in a fraction form, doesn't mean that it's not an integer if it simplifies to an integer. So another example here would be if we had 4/2. Now, while that is a fraction, when we simplify it, 4/2 is 4 divided by 2. It's really just saying 4 divided by 2, which simplifies to 2. And notice here there's no decimal or fraction remainder. It is just a whole number, this 2. If, for example, I were to have a different type of value here that was a decimal, but it ended up simplifying again to a whole number, we would also have an integer. So for example here, if I were to take 1.5 here, and I were to then have an operation that was going on here, and I multiplied that by, say, for example, 10, well, when that simplifies, this is 1.5 times 10, it gives us 15. So again, even though there was a decimal here and the 1.5, our answer eventually simplified to a number that is a whole number. And so it is going to end up being an integer once it is simplified. Let's think about another example where you might have a simplification. So what if we had square roots? Now, if you haven't done square roots before, just note we're asking ourselves what is the value here that we can find that is times itself. So 36 here can be broken into 6 times 6. 6 times 6 gives us 36. So the square root asks us what is the value that times itself gives us the number that's under this square root. And since the square root of 36 is 6, that is going to end up being an integer because it's a whole number. So even though at first it seemed a little bit weird with the radical sign, since it simplifies to an integer, we're going to end up having that. And that could be the case even if we, combine various things if, for example, we were to have the square root of 16 over, and let's say we put something here that will simplify nice, the square root of 16 over 2. So this example right here, again, it's a little bit unusual, but when we simplify, the square root of 16 equals 4, because 4 times 4 is 16. And now it's over 2. Aha, the numerator is bigger, and it goes into it without any decimal or fraction remainder. So 4 divided by 2, again, is 2. So that's an integer. And so to help just distinguish this last bit here, we'll just say not integers. So we'll give it a couple examples here of not integers, just to make this extra clear. If we had, for example, 1.7, again, there is a decimal here, and that will not work because we cannot have a decimal or fraction remainder. It can't be further simplified. For example, if we have 1/2, again, 1/2 could also be thought of as 0.5. It is a fraction that cannot simplify to a whole number, so it's definitely not an integer. If we have a value that keeps on going on and on forever without any kind of repetition, that's called the irrational number, and we'll get to that later. But for example, we could have the square root of 2, because that's not going to be a whole number. We could have pi. Again, pi goes on forever and ever without a repeating type of pattern to it, and since that has decimals to it, it could also be somewhat approximated as a fraction. It's not going to be a whole number, so it's not going to work. And the same could be said of negative numbers. If it's a negative 1.3, or if we have, for example, a negative 2 over 5. Again, all of these have fractions that could lead to having decimals or are just decimals. They're not whole numbers. They are not numbers that are in the one spot where you're counting up decimal value places. So again, integers are positive and negative whole numbers and inclusive the number 0. So hopefully this helps you kind of visualize what integers are and gives you some beginning clues as to things that are not integers.